In this video, we are continuing with prepositions and truth tables. We ended the last section by looking at the first 4 logical notations. Now we are going to cover the next 4. This table shows the 4 logical notations that we will cover. Now let us look at a slightly more complex example. Implication prepositions are if-then preposition. So, in this example, if it's raining, then it's cloudy. The implication P implies Q is false when P is true and Q is false. Pause the video and try constructing an implication table on your own, given the preposition if it's raining implies it is cloudy. Here is what a completed implication truth table looks like. Notice that P implies Q is false only when Q is false and P is true. Recall that the last column tells us the truthfulness of the expression. Given if it's raining implies it's cloudy, the truthfulness of the table is as follows. Row 1. If it's raining, then it's cloudy. This is true. If it's not raining and it's not cloudy, then it's false in row 2. Row 3. If it's not raining and it's not cloudy, this is true. And row 4. If it's not raining and it's not cloudy, this is true. Let us now look at a biconditional statement. Biconditional preposition connects statements such that P is true if and only if Q is true. The biconditional if and only if is the preposition that is true when P and Q have the same truth value and is false otherwise. Pause the video and try constructing the biconditional truth table on your own. Note that a biconditional statement is true only when P and Q have the same true value as shown on this table. This is when both variables are true and when both variables are false. Take a moment to study this if you did not get it straight away. Now, let us move on to universal quantification. The universal quantification set is represented by an upside down A. The X is represented the members of the set. This example is of all the letters of the alphabet that we are going to consider. A universal quantification sentence says that for all X in the universe of discourse, which is just the set of all the things we want to talk about, the subset P is true. For example, for all X in the English alphabet, the letters in the subset P are true because they are the subset of the universal set. Let us consider this example. Let us say that we have a universal set that contains all teachers. If we assign teachers the variable X, and we take a subset P of a teacher, and another subset Q that is Y's, what would this statement mean? This is how we would read this statement. If X is a teacher, then all X's are Y's. In other words, all teachers are Y's. Now, look at this example. PX is a girl and QX is human. Can you answer this statement? If X is a girl, then all girls are human. Or other words, all girls are human. Next, we will look at the existential quantification represented by left-facing E, which means there exists. In the previous example, we saw that in the universal quantification we are working with all members in the universe of discourse, all of the sets we want to talk about. By contrast, in the existential quantification, we work with the understanding that there exist some members. The existential quantification of a predicate Px is the preposition there exists an X in the universe of discourse such that P is true. If we say that Px means that X is a universal student, a university student, and Q means that X is a genius, then what does this statement mean? It means there is an X such that X is a university student and X is a genius, or at least one of the university students is a genius. Let us take a look at another example. Let us say that the universe of discourse is all real numbers. What then does this statement mean? Notice we have the universal and the existential quantifications in this statement. These statements read, for every x, there exists an x such that x plus y is 200. Is this true? Yes. In this section, we reviewed how logical operators work when they combine prepositional statements and how truth tables help us to visualize the results of this combination. We also reviewed universal and existential quantification. These concepts are important, fundamental part of discrete math. So please feel free to review this video again and make sure that you have a solid grasp before moving on.